Dilute aqueous solution of Na2SO4 is electrolyzed using platinum electrodes. The products at anode and cathode. When Na2SO4 solution is released, here the available ions are Na2SO4. It will give us 2Na plus SO4 minus 2. H2O, because it is aqueous, we have H plus ions and OH minus ions. So in this electrolysis, out two cations are available. One is Na plus ion and other one is H plus ion. Out of these two ions, H plus ions are preferably reduced than sodium ions. So it will give us H2 gas at cathode. Out of SO4 minus 2 and OH minus, in the previous case, if Cl minus and OH minus are there, Cl minus ion preferably discharged. Out of SO4 minus 2 and OH minus ions are discharged at anode. So 4 OH minus ions gives 2 H2O plus O2 plus 4 electrons. So at anode, oxygen gas is liberated. Oxygen gas is liberated at anode and hydrogen gas is liberated at cathode. So anode then cathode. So O2 and H2. First option is correct. Next one. When aqueous solution of lithium chloride is electrolyzed using graphite electrodes. So lithium chloride LiCl, it ionizes to give Li plus ions and Cl minus ions. Since it is aqueous, you have water, it gives us H plus ions and OH minus ions. Now this is pH related question. That means it's depend upon H plus ions concentration. pH means pH is equal to log 1 by concentration of H plus. That means pH is reciprocal log of H plus ion concentration. That means if H plus ion concentration is decreased, pH increases. H plus ions concentration decreases, pH will increases. Now in this electrolysis, H plus ions are removed as H2 because at cathode out of Li and H plus ions are preferably reduced as H2. That means during this electrolysis, H plus ion concentration is decreasing. When H plus ion concentration is decreasing, pH will increase. So pH of the solution, resulting solution increases. Second option is correct. The products formed when an aqueous solution of NaBr is electrolyzed in a cell having inert electrodes. If we use inert electrodes, when NaBr is electrolyzed, Na plus NaBr ionizes to give Na plus and Br minus. Sorry. Br minus. Now we have aqueous solution means we have H2O. So H plus ions and OH minus ions. Now out of Na plus and H plus ions are preferably displaced. That means 2H plus 2E minus gives H2. So H plus ions are removed. Then out of Br minus and OH minus ions, Br minus ions are discharged. 2 Br minus gives Br2 plus 2E minus. So this is also discharged. So H2 is discharged at cathode, Br2 discharged at anode. Then the remaining ions are Na plus and OH. These two combine to form NaOH in the solution. So in electrolytic cell you have NaOH, and at anode you have bromine, and at cathode you have hydrogen. So third option is correct. The reactions takes place at anode and cathode in any electrolysis. Electrolysis is a redox reaction. Oxidation will take place at anode and reduction will take place at cathode. Oxidation at anode, reduction at cathode. Oxidation, the reaction takes place at anode and cathode. Anode oxidation, cathode reduction. So they are asking first anode then cathode. So first option is correct. Oxidation and reduction. Electrode through which the electrons enter the electrolytic solution. Electrode through which electrons enter into the electrolytic solution. So in electrolytic solution, electrons will enter into cathode. Through cathode, electrons will enter into electrolytic solution. There, cations will take those electrons and reduce as atoms. So, through cathode, electrons enter into the solution. Whereas electrolysis is in progress, if cathode plate is removed, what happens? That means in any electrolyte, when it is in a fused state or in aqueous solution, free ions are present in the electrolyte. These ions are in random motion in all directions. When external EMF is applied through electrodes, then movement of ions will be streamlined. All anions will move towards anode and all cations will move towards cathode. We can stop the electrolysis by disconnecting the external EMF or battery, or by withdrawing any one of the electrode. If any one electrode is removed, the second electrode cannot do anything. So here the question is, during electrolysis, when cathode is removed, that means electrolysis is stopped. When electrolysis is stopped, the movement of ions will become randomly, because before, when EMF is in force, cations will move towards cathode and anion will move towards anode. When electrolysis stopped, ions will randomly move in all directions. So now let us observe the options here. The movement of ions is stopped. This is wrong. Movement of ions is not stopped. The ions move at random, as this is correct. All ions move towards anode. This is also wrong. Only anions will towards, this is also wrong. Even anode is present. The circuit is not completed due to the withdrawal of cathode. So electrolysis will stop and ions will move randomly. So second option is correct. In the electrolytic cell, flow of electrons is from. In electrolytic cell, flow of electrons. So in electrolytic cell, electrons are released at anode. At anode, anions, for example, 2 Cl minus ions give Cl2 plus to E minus. So here from anode, electrons will reach the battery, then they will move towards cathode. Their cations will approach cathode, there they take those electrons to discharge as H2. So here electrons are released, here electrons are absorbed. So electrons will move from anode to cathode through external circuit. So cathode to anode, cathode to anode, anode to cathode through external circuit. So this is correct. Through external circuit, remember, it is not within the solution. Electrons will move from anode to cathode with external circuit. In electrolysis, dilute H2SO4, which is liberated at anode, is in the presence of inert electrodes, which is liberated at anode. In dilute H2SO4, we have H2SO4, we have 2H plus and SO4 minus 2 ions. So dilute means water is there. If water is there, you have H plus ions and OH minus ions. Now they are asking at anode. Out of these two anions, OH preferably displaces. The reaction is 4OH minus gives 2H2O plus O2 plus 4E minus. So O2 gas is liberated at anode. Which process occur in electrolysis of aqueous solution of nickel chloride at nickel electrode? So in electrolysis at anode, oxidation will take place. If inert electrode is used, anion present in the electrolyte will discharge at anode. But if metals, active metals are involved, are present at anode, they dissolve and goes into the solution. So here the problem is nickel chloride. Nickel chloride ionizes to give nickel ions and Cl minus ions. Aqueous solution. In aqueous solution you have H2O, so H plus ions plus OH minus ions. Now here we are using nickel at anode. When nickel is used at anode, this nickel will goes into the solution as Ni plus 2 ions plus 2E minus ions. Actually, if inert electrode is used, platinum or graphite is used, in this reaction, the Cl minus ions are supposed to liberate as Cl2 gas at anode. But when nickel active metals are present at anode, remember at anode, not at cathode. If active metals are used at anode, they oxidize to give the respective ions and goes into the solution. If it is a inert electrode, this reaction will take place. Now nickel electrode, this reaction will not takes place. So nickel ions will goes into the solution. This reaction is fourth option is correct. Next one. Molten CuCl2 is electrolyzed using platinum electrodes. The reaction occur at anode. So platinum is a inert electrode. Platinum is a inert electrode. So CuCl2 you have CuCl2, you have Cu plus 2 ions and 2 Cl minus ions. Now platinum electrode is used at anode. When platinum electrode is used at anode, these anions will discharge. 2 Cl minus gives Cl2 plus 2 E minus. So chlorine is liberated at anode. Suppose if in this reaction, if you use copper as anode, then the reaction may be Cu gives Cu plus 2 plus 2E minus. In the both the cases, oxidation only takes place. If active electrode is involved, copper goes into the solution. If inert electrode is involved, chlorine is liberated. During electrolytic reduction of alumina, the reaction at cathode, alumina means Al2O3. Al2O3 ionizes to give 2Al plus 3 plus 3O minus 2. Now here in alumina, at cathode the reaction is Al plus 3. What is it? Electrolytic reduction of alumina. So Al plus 3 plus 3E minus gives Al. Because here they have not given as an aqueous or something like that. We can consider it as a fused alumina. So here the reaction is this. So here the third option is correct. When an aqueous solution of copper sulfate is electrolyzed using copper electrodes, the reaction at anode is represented by. When aqueous solution of copper sulfate is electrolyzed using copper electrodes. So here copper electrodes are used as anode. When metals, that is active electrodes, are used at anode, instead of anions, the metals itself oxidized and goes into the solution Cu plus 2 plus 2E minus. This reaction is only when active electrodes are involved. When inert electrodes are involved, anions of the electrolyte will discharge at anode. So fourth option is correct. Which of the following reaction is possible at anode? At anode, oxidation will take place. Oxidation will take place at anode. Now we have to find out of these options which is an oxidation and which is a reduction. So at anode, this here it is plus 3 oxidation state, here plus 6 oxidation state. So this is called as oxidation. F2 0 oxidation state, ఇది -1 oxidation state, this is reduction. Here also 0 oxidation state, here it is -2 oxidation state, so this is reduction. None of these. So first option is correct. Aqueous solution of CuSO4 is electrolyzed using inert electrodes till the blue color of solution becomes colorless. The colorless solution forms. So aqueous CuSO4 means CuSO4 ionizes to give Cu plus 2 plus SO4 minus 2. Aqueous means H2O gives H plus 2H2O gives 2H plus 2OH minus. Now here during this electrolysis, out of copper and hydrogen, the reduction potential of hydrogen is 0, whereas copper is plus 0.3 0.34 volts. So since its reduction potential is more, copper will discharge at cathode. That means Cu plus 2 plus 2E minus gives Cu. So it is less reactive than hydrogen. If sodium, aluminum, magnesium, such active metals are present, H plus ions are liberated as H2. But here copper is less reactive than hydrogen. So if metals like copper, silver, mercury, etc., if they are present, they discharge at cathode instead of H plus ions. So copper will disappear. Then out of SO4 minus 2 and OH minus ions are preferably displaces. 4OH minus gives 2H2O plus O2 plus 4E minus. So when these two are disappear, that means so the remaining ions here are H plus and SO4 minus 2. These two will give H2SO4. This is colorless solution. After complete electrolysis of aqueous CuSO4, the remaining substance colorless solution is H2SO4. After electrolysis of aqueous solution of NaCl using platinum electrodes, the pH of the solution. So aqueous solution of NaCl contains NaCl gives Na plus ions and Cl minus ions. Aqueous means water, H2O. It will have H plus ions and OH minus ions. So during electrolysis, H plus ions concentration is decreased because 2H plus 2E minus gives H2 and liberated as H2S gas. That means H plus ion concentration is decreasing. H plus ion concentration is decreasing means pH will increase. So increase of pH will takes place. So platinum electrodes, the pH of the solution increases. Aqueous NaCl solution is electrolyzed using platinum electrodes. What is the product formed at cathode? Aqueous NaCl, in NaCl you have Na plus ions and H plus ions. Out of these two ions, H plus ions will removed as H2 at cathode. So at cathode, H2 ions are released. An anode, at anode the electrolysis of fused sodium chloride. When fused sodium chloride means Na plus and Cl minus ions. Fused sodium chloride at anode, Cl2, Cl minus is oxidized as Cl2. Oxidized as Cl2. So Cl minus ions are oxidized. So second option is correct. In electrolysis of NaCl, when platinum electrode is taken, then H2 gas is liberated cathode with Hg cathode. It forms sodium amalgam. This is because here this is some ambiguity question, but by convention we say that more voltage is required to reduce H plus ion at Eg at platinum. So there is it may be there is ambiguity, so I cannot say because I verified so many books. High voltage are they are setting, but they are not giving proper reasons. Which of the following ions discharged at cathode? Which of the following ions discharged at cathode when an aqueous solution of sodium hydroxide is electrolyzed? When sodium hydroxide, aqueous solution of sodium hydroxide is aqueous, means hydrogen gas is liberated. Whatever the substance it is, if it is aqueous, except for copper, silver, like that, at cathode hydrogen gas is liberated. During electrolysis of fused NaOH, when fused NaOH is electrolyzed, NaOH, it will give us Na plus and OH minus. So Na is discharged at cathode, Na plus E minus gives Na. But here Na was not given. Options at anode, oxygen is liberated. So fourth option is correct. These are single answer questions. So fourth option is correct. Aqueous solution of AgNO3 is electrolyzed using inert electrodes. At the end of electrolysis, aqueous solution of AgNO3 is electrolyzed. When AgNO3 is electrolyzed, we have Ag plus ions and H plus ions. So since it is less reactive than hydrogen, Ag plus ions are discharged at cathode. So H plus ions are not involved. So there will be no change in the pH. So pH of the solution remains unchanged. pH change will take place only when aqueous solutions of active metals are involved, which are present above hydrogen in the electrochemical series. If such metal ions are present in aqueous solutions, then pH is increased. But in the case of aqueous solutions of copper and silver, these metals discharge preferably than H plus ions. In such cases, there will be no change in pH. An aqueous solution containing 1 mole per liter of each CuNO3, AgNO3 and Mg plus 2 being electrolyzed using inert electrodes. The values of standard electrode potentials. So values of standard electrode potentials. So bottom Ag above we have Hg, then on the above Cu, on the above Mg. Now the question is, with increase of voltage, the sequence of deposition of metals on cathode will be, first Ag will be deposited first, then Hg, then Cu, then Mg. So Ag, Hg, Cu, Mg. So here aqueous solutions, when aqueous solutions are present, magnesium cannot discharge, because in aqueous solutions active metals like magnesium, which are having negative reduction potential, they cannot discharge. Only these three will be discharged. So the sequence is, third option is correct. At cathode, the electrolysis of aqueous Na to SO4 gives. At cathode, electrolysis of aqueous Na to SO4. In aqueous solution, when metals are involved, active metals are involved, at cathode, hydrogen gas is liberated. The electrolysis of an aqueous solution of KNO3 between platinum electrodes gives aqueous solution. Aqueous solution means hydrogen at cathode. In electrolysis of aqueous solution of sodium chloride solution, which of the half cell reaction will occur at anode? At anode, chlorine is discharged. So this half cell reaction takes place at anode in aqueous NaCl.